So we've seen a lot of good ideas that emerged, and some of these ideas changed how we build web applications, and other ideas that were not so good, and we discarded them because they did not work. We heard a lot of hype, a lot of people being very excited about something that they like, and other people not so excited and not liking nothing so much. And hearing all these conflicting ideas can be really difficult. It makes it really difficult to figure out which technology to use. It's especially difficult when you have to choose a technology for an organization that is going to be ultimately maintaining your whatever it is that you choose for the next 5, possibly 10 years. So I want to talk to you about the evolution of the web, evolution of the web frameworks, and help you give you some context as to kind of what went on, and hopefully give you some information that could be useful in trying to figure out what tool would be right for you and for your organization. Like that kid. So my name is Mankovski. I'm CTO of ThisDot. We're a mentoring and apprenticeship company. And I want to walk down the memory lane back to Backbone.js, which is the first library that became popular for making for building for the web in a way that actually kind of felt like you were programming. And Backbone was the first framework to popularize using model view in the JavaScript ecosystem, like in the JavaScript libraries. It was one of the first to kind of make it something that people used, and it introduced this idea of separating the model, which in Backbone represented the data, and the model represented the data and the business logic, and the view is the presentation of that data. And the model communicated with the view by firing change events, and the view would listen for that event, and it would update the view accordingly. So in Backbone, Backbone was what they would call the framework, or a templating agnostic, meaning that it didn't really give you any way of, it didn't provide any way of updating the DOM. It left it up to the developer to do that. And around the time that Backbone 1.0 came out, AngularJS came on the scene, and it became really popular very quickly because instead of focusing on the model, which what Backbone was doing, AngularJS focused on the view. So Backbone was AngularJS was one of the first tools in web ecosystem to come up with this idea of making making HTML more dynamic by adding behavior to HTML. And it was one of the first libraries to make compiling templates available in the browser. And unlike Backbone, which left it to the developer to apply changes from the model onto the DOM, it introduced the idea of binding your model to the view, so you could actually change your model, and the view just updated itself automatically. And so it became really popular really quickly, partially because it was really easy to use very easy to use AngularJS in an application, and it was easy to get started with. And the fact that it was made by Google kind of went a long way to giving it credibility, especially amongst people who were not familiar with building web applications. And about the same time, we saw the kind of introduction of the Web Component Specification. And the Web Component Specification promised the ability for us to be able to create custom widgets, and then allow us to share these custom widgets and be able to compose these custom widgets into kind of dynamic user experiences. And the Web Component spec consisted of 4 specifications. The template specification, which provided some markup to the web component when the web component is being rendered. And the custom element spec described how you could represent the web component with a custom element, with custom HTML element. And Shadow DOM described how you would isolate the component from its context. So when you render that component, you can't reach into the component to change the behavior unless you pass an argument to it. So an image tag is a good example of that isolation because you don't know how the actual internals are implemented and what causes the image to display, but you know if you pass it an image, it's going to show you that image. And lastly, HTML imports is a mechanism of actually being able to load the web component into your web page so you could consume it and render it in your page. Now, the problem was that web component specifications weren't available in the browser, so you couldn't. So with the specification, you needed something to actually make it work, and so Google created Polymer, which was a polyfill that made it possible for us to use web components in the browser. And very early on, it was awesome because you could compose it. It was easy to render. But the problem was that we didn't actually know very much about what it takes to be able to render a large tree of custom elements and be able to make that performant. And if you make a change, how do you make that like apply that change to the DOM in a performant way? All of that was still to be discovered, and a lot of early adopters of Polymer were finding performance problems that the framework needed to address for later, kind of down the road. So at the same time, while this was happening, a group of people who were inspired by what Ruby on Rails was doing. So Ruby on Rails, they were inspired by Ruby on Rails, and they wanted to create a framework that would be open source, community-driven, and it was based on conventions over configuration. It provided everything that you need to be productive building for the web. And so this group of people started off with Sprout Core. They forked Sprout Core, and they created Ember, Ember.js. But the challenge with Ember.js was that when you start building a conventions-based framework, you need to know what the conventions are. So they had to go and find what were the actual conventions for building modern web applications at that time. So they went and they looked at a bunch of backbone apps, which were in production by that point for a couple of years now. And so they noticed some patterns. One of the patterns was hierarchical views. So there's the idea that there are some views that contain other views, and depending on which part of the application you're in, you might always see, for example, the nav, but you might not see the components page, like my account page in your list view. Like depending on which section of the app, you might show different things inside of the main view. And the second part, the second pattern that they identified was the significance of the URL. One of the challenges that we saw with a lot of backbone applications at the time is that a user could interact with the application, but once they got the application in a state that they wanted to be in, they couldn't actually do, like, it wasn't portable. So a good example of that is if you're trying to buy a ticket online and you found a ticket that you want, but now you want to take that ticket and send it to a friend so that the person can book the same ticket. You can't actually do that because there is no way of actually serializing that state and making it portable. So there were some applications at the time that they would give you like a specific URL. They would generate some way of, like they would make a special way of generating your URL. But the only thing you were left with, either that or like take a screenshot and send it to your friend. So what they did was they combined the two things together. They took the hierarchical views and combined it with the significance of the URL to create the routing system. So the routing system was the URL served as the entry point into the application. And then depending on which URL you were navigating to, it would render different views based on that. And the first version of Ember was released in August 2013, and it was created with a group of open source contributors. It had MVC architecture, it had a routing system, and it had components with templates. So the components were added to Ember like kind of last minute because it wasn't really clear at the time what the significance of them was going to be. They were in the web component spec, so components in Ember were kind of like, oh, they look like a good idea, and they're going to look like kind of like web components, but let's put them in. But it wasn't really like, we didn't know until later what that actually meant. So at that time, kind of the main frameworks that were available, they all relied on object mutation and they all relied on bindings to to apply changes to the DOM. So you'd mutate some object, and through some kind of mechanism of tracking that change, those changes became reflected in your page. And then we had React come on the scene. It kind of came out of nowhere for a lot of people. Facebook released React, and it was the first framework to introduce this idea of having a functional render pipeline. And it was the first framework to kind of frame components as functions that return DOM. And parameters that you pass into a component being arguments of a function. So this idea of thinking of a component as a function was something that only really landed when React started to talk about components. So this is an example of where if a title property changes, then the component returns a new the render function is invoked, and the component returns a new DOM tree. One of the things that was significant about this is that React also introduced a way of making that actually work performantly. So if you have a lot of components and you change something at the top, if you return the component tree, you had a way of performantly apply, like basically whatever it is that was returned by the functions, you had a way of applying that to the DOM. And the way that it did that is that whatever was returned by the function, whatever DOM tree that you received from your render, you would take that and compare it to what you rendered before, so you can figure out what needs to be changed, and then you apply only those changes to the actual DOM. And so that's the whole like virtual DOM diffing thing, and that was really important because React was able to do something that Polymer was not able to do, which is show how to build components, a component architecture or application with components in a way that was actually performant. At this time, AngularJS was having a lot of time, developers who built large Angular applications, AngularJS applications, they were struggling with dirty checking and performance problems caused by mutating objects and figuring out if those objects have actually changed. In Ember, the Ember community had a problem with two-way bindings and reliance on observers that didn't scale very well for large applications. So this was something that we were finding out at about the same time. And so React was everywhere. We were seeing people rewriting large Ember applications to move to React. People who were having performance problems in Angular were moving to React. Some people were trying to figure out how to get React working with Angular. Backbone developers were rewriting the applications to React. And then some very brave individuals or groups of people, they would wire React onto Backbone so that React functioned as a rendering engine or the rendering layer for Backbone. This arrival kind of hit Ember really hard because what you see here is on the right side, that's React rendering lots of data. In the middle is Angular. You can see it wasn't actually so bad. But Ember did really bad on re-rendering. At that time, this was a really huge issue for Ember. So the Ember community came up with a way that they basically decided that the only way to survive this is to adopt the ideas that React introduced and pull them into the Ember framework. And so over 4 minor releases of Ember, there was a plan to prepare the Ember applications that were in production to make them suitable for the new rendering layer that was coming in that is going to be inspired by React. And so over the course of 4 releases, they deprecated views, so removed views from the framework. They introduced a CLI tool, a command line tool for building applications so that you could easily upgrade versions of Ember and the render pipeline without having to make everybody do a whole bunch of manual work. And the framework embraced component architecture. And this process, the Ember community coined stability without stagnation. Using this process, lots of big production applications were able to go from pre-React world to we're living in React world without having to rewrite the entire application. So while Ember was learning from React, React was learning from Ember. One of the people who left Ember community for React, the person forked router.js, which is a library that Ember uses for routing, and created a React router, which is now one of the most popular routing libraries for React. One of the other major contributions that Ember made to the ecosystem is introduce this idea of using a CLI for building front-end projects. This was, I think, to us right now, looking at a list of CLIs that are available. So we have one for React. Angular CLI was a fork of Ember CLI that is now being rewritten. Polymer has a CLI. Vue has a CLI. Preact has CLI. With this kind of landscape, we kind of take it for granted that CLIs are a thing. But when Ember started, it was something that Ember had to lead with because they didn't exist. And around 2015, but mid-2015, Angular community in the core team is starting to realize that AngularJS is coming to a kind of evolutionary dead end, because Google needed their developers to have a tool that they could use to build large applications, and AngularJS was not going to be that tool. And so they needed to create something that is going to be feel like programming for people who are really serious about making like really good quality software. And so Angular core team started to work on a new project, which they call Angular, as opposed to AngularJS. And Angular is not, they call it a platform, because what they want to do is they want to give the developers who are building for the web, everything that the person would need, or everything that the team would need to be productive in one place. And Angular wholeheartedly embraced component architecture as a primary way of building applications. It's still maintained as a spiritual successor to AngularJS, so it has directives, it has similar syntax that has been mildly improved. It's been improved. But the important part is that you can now render a custom element, and that custom element is going to be an Angular component. And Angular is one of the first libraries to adopt TypeScript as its primary programming language. So with TypeScript, we get classes, modules, and interfaces. So for anybody who has experience, and it has IntelliSense support in editors like Visual Studio Code. So for anybody who is comfortable with Java and you like the tooling, or C# and you like the tooling that a full-fledged IDE gives you, you would feel right at home using TypeScript and Visual Studio Code. So Angular is really trying to make the professional developers happy. Polymer 2 has been released recently, May 2017, which has an improvements in the binding system. It eliminates the need for such a heavy polyfill. I think it still requires some polyfills, but they're not as domineering as they were before. And Polymer embraced the latest JavaScript standards. So when we look at the landscape today, what we see is that most of the frameworks have very similar performance. The performance differences they have are not really noticeable to most users, and it's not as easy to walk yourself into a performance problem, and performance problems are much better understood. So performance-wise, these frameworks are very similar. They all embrace component architecture as a primary way of building applications. They all have routing. They can all use state management techniques like Redux. And they all provide mechanisms to do server-side rendering. So how do we choose a framework in 2017? And I would suggest that the way you think about what tool to use, I would suggest that you think about the demographics of your organizations and think about what kind of programming you want to do. Because React is a tool that is designed to be a thin layer, and one of the libraries that you put together, you essentially assemble your framework for your particular for your project or for your company. And React is really well suited for developers who are already comfortable with functional programming and immutability. And if you have a team of experienced JavaScript developers, they're going to feel very comfortable and very happy with React. There's also the fact that with React, you can build, there are lots of different things you could do with React. So if you're, like React community is like on a cutting edge of the kind of things that you can use web technology to build. So you could use React to target native with React Native, and you can use React to target VR with React VR. Angular is a framework that is being designed to work really well for enterprise developers and developers who really care about having a high-quality IDE experience that supports them in their development environment or in the development process. So if you're familiar with if you love your IDE and you have developers who come from Java background and C#, Angular is going to feel right at home for them. And with TypeScript support, and Angular is one of the few frameworks that has a really robust ecosystem of third-party component vendors that you just kind of buy a library and just start using it right away. And you can also build native applications, performant native applications using NativeScript with Angular. Ember.js is really well. It's being optimized for the craft developer. The kind of person who takes their abilities to build applications as a craft that they're going to perfect over time, and they're going to become increasingly more and more productive. The building applications with Ember today is extremely easy because the ecosystem is very well established. They've been building on top of shared primitives for longer than any other framework on the market, and everything is very well integrated. So a lot of SaaS vendors, companies that have to maintain applications over a long time, Ember kind of spiritually aligns with them very well with the kind of priorities that they have. If you're planning to maintain something for a long time and it's a big part of the value of your business, then Ember is a really good tool to use. Polymer is really good for large organizations that are looking to have a style guide that they could give to their developers and then or use in their organization where they can sprinkle dynamic behavior throughout the application, throughout their entire organization in whatever applications they want to use, and in a way that doesn't require very much JavaScript. So if you have developers who are not really who are not going to invest into really learning JavaScript, Polymer is really good for that because you could just inject a good component into any HTML page and kind of go from there. And that's me. We do mentoring and apprenticeship and we help companies be better at building web applications. And my name is Mankovski.